Question number 26. A circuit is created with the cell, two parallel conducting wires and a movable metal rod of length here. See, he says about this conductor over here. Okay, two parallel conducting wires, the movable length of the rod L. And then when the uniform magnetic field is directed outside the field, it's coming towards me. Okay, the metal rod moves to the right with velocity v. It's moving like this. The initial current in the circuit is I. What is the direction of the current through the circuit? The initial force on the metal. Initial force on the metal. You see, all the forces given are BIL sin 90, BIL sin 0 here. The first thing is that when I connect a cell and I put a magnetic field and you expect the rod is moving, why should it move? It should move only when there is a force acting on it. There's no slam, there's no something like a ramp over there. It's a plain one, so it's not given anything like that. So it should move only when there is a force acting on it. So therefore, if a force is acting on it, then the force is not zero. Remember this. So if the force is not zero, then definitely these two are incorrect. Because sin 0 becomes 0, so definitely this becomes 0. So this is incorrect. So very clearly by the diagram itself, you are able to say what is happening. Now let us move on to the next one. Now here you need to find out what is the direction of I. Any two of these are correct. Direction of I. How do I find this? Now when I say the particle is moving like this, the rod is moving like this, there is a force acting. Force will also act like this only. This is your force over here. Magnetic field is acting outwards. Use the rule once again. So what is this now? This is a current carrying conductor kept in an external magnetic field. So towards it. Now B. First what I have to do is I have to align my B over here. What I have to do, I have to twist my finger like this. Very difficult to do it. Okay. It pains me a lot in the ankle. What I do is I'm not doing that. I'm keeping it like this. Okay. So now I'll keep the, suppose if the magnetic field was directed inwards and the force was directed in this direction. Was directed in this direction. Magnetic field directed in this, force in this direction. The current would have been downwards. Current would have been downwards. But unfortunately, what's happening here? Here, the magnetic field is not directed like this. It's going outward. Which means I cut this finger, put it to me. I keep it like this over here. Right? See? I keep it like this over here. I keep it like this over here. So as a result of this, I'm not able to see. Okay. So therefore, now, so when it is like this, when you flip one of them, you are free to flip this also. So this flip outwards, okay, upwards over here. So therefore, the current is moving in this direction, this direction. If it has to move like this, it has to come like this, it has to go like this. What direction is this? This direction is your anti-clockwise direction, right? It's your anti-clockwise direction. So therefore, the option is B. I hope this is clear.